Examples involving exponential function and the natural logarithmic function. Now in example 1, we asked to solve for x, and we have e to the 2x minus 2e to the x equals to 8. So let's just focus on e to the 2x. E to the 2x is e to the x multiplied by itself. So it gives you e to the x squared. So if you have a look at the question, e to the 2x minus 2e to the x equals to 8, can you see that it is a trinomial? And we're going to write it in standard form. So we get e to the x squared minus 2e to the x minus 8 equals to 0. Now, for me to solve for x, I need to factorize this trinomial, and I'm going to use a method called k substitution. I'm going to replace x with the variable k. So I let e to the x equal to k. And this helps me with the factorizing and the solving. So e to the 2x is e to the x squared, and so I will have k squared minus 2k minus 8 equals to 0. This can be factorized quite easily. The factors of 8 that we need will be 4 and 2. So we have k minus 4 multiplied by k plus 2 equals to 0. I now know that either k equals to 4 or k equals to negative 2. So I replace k with e to the x because initially I said let k equal to e to the x. So I have that e to the x equals to 4 or e to the x equals to negative 2. So looking at the first solution, I need to solve for x, and I have e to the x equals to 4. What I'm going to do is I'm going to write it as a log. So I know that x will be ln of 4, or x will be log of 4 to the base e. So I write x equals to ln of 4. And then using my calculator, I can calculate the numerical value of ln of 4. So on the calculator, the ln button, so you press ln 4 equals, and then you will get 1,386294361, and then you can simplify your answer by rounding it off to the required decimal places. Let's round off to 3 decimal places, so we get that x equals to 1,386. Leaving your answer as ln 4 is also very acceptable. Now let's look at the next solution. We said that our second solution would be e to the x equals to negative 2. Now I'm going to draw a little sketch of the graph e to the x. And if you recall, the graph of e to the x, e is an exponential function. So the graph of e to the x was an increasing exponential function that had a y-intercept at x equals to 0 and y equals to 1. Now the question wants me to find the y value at negative 2. But looking at the sketch of e to the x, we see that it has a range of y greater than 0 for all real values. And that is because we also learned that the x-axis is your asymptote. So e to the x equals to negative 2 has no solution. So the only solution to this equation is x equals to ln of 4, or x is approximately equal to 1,386. Example 2 of examples involving the exponential function and the natural logarithm. We are once again asked to solve for x, but now we have ln x squared plus ln x minus 6 equals to 0. Immediately I'm going to use k substitution, and I'm going to let ln x equals to k. And I do this to help me to simplify or to factorize this quadratic expression that I have here. So I have k squared plus k minus 6 equals to 0. This is factorized. The factors will be k plus 3 multiplied by k minus 2 equals to 0. Solving for k, we see that k can equal to negative 3 or k equals to 2. So I know that k is ln of x, so I now say ln of x equals to negative 3 or ln of x equals to 2. So for me to solve for x, I now need to rewrite this in the exponential form, reminding myself that ln of x is log of x to the base e. So if I write this in exponential form, I will get x equals to e to the negative 3 or x equals to e squared. And then once again, you may leave your answer in this format, or you can actually work out the numerical values on the calculator.